Hello, science family. Today we're going to be looking at distillation. First, I want to show you the setup for distillation so that we can get a better idea of how this works. So you'll see we have a Bunsen burner on the bottom and then a boiling flask on top. If you notice that in this flask, there's this glass arm. And if we disconnect this, you can see that this little glass arm is actually going to be connected with a cork to something we call a condenser. Now, what a condenser does is you'll notice it has two tubes coming out of it, and it actually is connected over here to the sink. If I turn the sink on water really low, the water will actually start coming through the tube and into the condenser and fill up. When that cold water comes through the tube, it's then going to drain out back into the sink. So why are we doing this? Well, what's happening is this. We're actually running cold water through this condenser, and inside is a tube that doesn't actually get wet, just the outside of the tube does. But what's going to happen is this. We're going to boil something, and when the vapor goes through this little tube, it's eventually going to hit the glass, the inside tube, that's going to stay cold from this cold water. When that gas hits the cold water, it's then going to condense back down and drip out the end and into this beaker. And that's how distillation works. We're actually going to be able to separate two liquids because they have different boiling points. And that's what we're going to do. We're actually going to take this right here, which is a mixture of alcohol, water, and green food coloring. Now, alcohol and water are two different substances, and if we boil them, they boil at two different temperatures. So distillation is going to take advantage of the fact that alcohol boils at a lower temperature than water does. And what we'll see is that the alcohol will come out first, and in this boiling flask, we'll leave behind the water and the food coloring. So let me set that up for you guys, and we will start to see how distillation works. So right now, we have the distillation setup ready. If you notice, I have my Bunsen burner on, and it's slowly starting to heat up this green liquid. Remember, this green liquid is actually a homogeneous mixture of green food coloring, water, and something called ethanol. Ethanol is a lab-grade type of alcohol that can be used for different things. Now, the problem is once those two liquids are mixed, it's hard to separate them. It's not like we can strain them out like water and coffee grounds and things like that. So as we heat it, what's going to happen is the alcohol is going to boil first, and when it does, it's going to turn to a gas, and that gas will eventually travel and hit this cold tube. Remember, the outside of the tube of water is surrounded by cold water that's being constantly cycled from the sink and down into the drain. If that water vapor hits that cold tube, it will condense back down into a liquid and then drip out there. So what we're going to do is keep an eye on when this starts to boil. If you notice too, I put little silica beads in there also to help with the boiling so that the boiling doesn't get too rapid or it starts splattering and spurting and you get some of the mixed liquid into there. Also, I wanted to point out that we have a thermometer. The thermometer is very near the elbow of this boiling flask in order to help recognize what temperature is that liquid going to come out at. What that can do is allow us to figure out what liquid is coming out first so that we can separate the two. When things boil, they boil at a constant temperature. So when we start heating all of this up, I think we're going to start to see that around the same temperature, one liquid's going to come out. And then at another temperature, something hotter, a second liquid's going to come out. So my prediction is that ethanol, which boils at an earlier temperature, will come out first, and then the water will come out second. So let's let this heat up. And once it starts boiling, I'll bring it back to show you what exactly is going on. All right, well, it is safe to say that something is starting to boil. And as it boils, that vapor is going to start coming in and condensing back down to a liquid. So the question is, let's see if any liquid starts coming out of here anytime soon. And there you go. A liquid is starting to come out of solution. Now notice that liquid has no green color. The food coloring is not in there. So whatever is coming out right now is boiling at a certain temperature. Look at that. It's between 75 and 80 degrees, right around 78 degrees. Now I know for a fact that ethanol boils right around 78 degrees. So what we are doing is, even though this looks like the whole liquid is boiling, only the ethanol inside of there is boiling and the water is still a liquid. But the ethanol is boiling, hitting the cold condenser tube and coming out the other end. And that's how we can actually physically separate two mixed liquids together. Because obviously we can't strain them, they're both liquids. So distillation is a way to actually separate something you want from something that it's mixed with. There are many applications of distillation. If you look, there's different types of liquids that are distilled. And it all happens through this simple idea of a physical property known as boiling point. The fact that ethanol and water have two different boiling points allows them to be separated. Now take a look. This thing is still boiling, but if you take a look at the temperature, it's still right around 78, 80 degrees. So what happens is, as ethanol boils, it really doesn't get any hotter because any of the extra energy that's being placed into the ethanol then converts it from liquid to gas so that it can travel through the condenser tube. And then eventually it comes out as a liquid again. So pretty cool. So here's the interesting thing. What if I wanted to get my water sample as well, not just the ethanol out? Well, we could keep letting this boil, and as soon as we see that the temperature really gets above that 78, 80 degrees Celsius mark, we could then switch the beakers, put a beaker in between the boiling ethanol and water, and then once the water comes out around 100 degrees Celsius, we could then start collecting the pure water. So my question for you is, what kind of phase changes are going on right now with this? Also, think about the energy. We're putting in energy into this system to boil out ethanol. Then ethanol hits cold tubes called the condenser tube and comes out as a liquid. Think about the change in energy, maybe increase in energy, then decrease in energy. But in the end, this overall setup we call distillation. So I just switched out my beaker of the ethanol that was distilled. Now you might think, well, Mr. J, this still looks like water. How do I know? Well, if I take an observation and I waft, you can actually smell that it's ethanol, that there's nothing about this that's water. It has a very rubbing alcohol-like scent to it. So we can see the different properties of it and test it to make sure of its purity, that it actually is the liquid we say it is. But again, the fact that it has such an odor to it, unlike pure water, means that gives me a lot of confidence that this distillation worked. Pretty cool though, isn't it? Think about what applications that might have. And also think about like cleaning our drinking water. Unfortunately, distillation is not a common strategy to use because it takes a lot of energy, as you can see, to boil that liquid. All right, so ethanol is still coming out. And how do I know that it's not water? If I look at my thermometer, it's still around 80 degrees. So there's no way water could be coming out because we know water boils around 100 degrees. So last time to say this, but the physical properties of that liquid allow the two liquids to be simply separated by heating one off and boiling off that one liquid and then turning it back down into a liquid again. So that's distillation science, fam. I hope you see the value in it and also can understand the underlying principles behind how it works. Take care.